Welcome back to this discussion about exponential functions and equations. One of the most used applications of exponential functions would be the use of the compound interest formulas. So this video we're going to focus on how do we use those formulas. So there are really two main formulas that calculate compound interest. One of the formulas we're going to use will be the formula for calculating interest that is compounded n times per year, a specific number of times per year. And that formula is A is equal to P times the quantity, 1 plus R over N, and that quantity is raised to the product of N times T. Oh my gosh, a lot of letters. Why are there letters in math? Well, you'll see in a second. All right, and so the other formula that we're going to talk about is the formula for calculating interest that's compounded continuously. And this formula is A is equal to P times the value E raised to the product of R times T. All right, and so this particular formula you're only going to use if the application says that the interest is compounded continuously. So this is not getting paid at a specific interval of time. It's getting paid continuously. So let's talk about what do all these letters mean? What do all those variables represent? Because all of these things could be different depending on the situation. That's why we issue them variables. So what do they mean? Well, A really stands for the accumulated value. That means the amount that's in the account after a specific amount of time has passed and your interest has been paid. Okay, so what's there after you've gotten some interest, after some time has passed? P is the principal, which means what amount did you actually start with? What did you put into that account? Or we consider that the initial value in the account. Okay, so N is going to represent the number of times per year that interest is compounded. And notice that N is only in one of those formulas. Okay, so if there's a specific number of times per year that your interest is being paid, then we're going to use that formula and we're going to use N as that number. So for example, let's say our interest is compounded monthly. We get paid monthly. How many times per year is that? Well, that would be 12. So N would equal 12 here. But if your interest was compounded daily, what if you got paid every day? How many times a year would you get paid? Well, that's your N value, and so that would be 365. Okay, so how about R? R represents your interest rate, but we are going to use your interest rate as a pure decimal. That means we're not going to use it as a percentage. So if we have an interest rate of 6.215%, we're actually going to percent it per 100 and make that into 0.06215. Okay, and then the last variable that we need to think about is T, which, as is often the case, represents time. And when we're talking about compound interest, T is often measured in years, but it doesn't have to be. All right, so let's look at an example. Here's an example. Suppose you've got $12,000 to invest. Well, if you have $12,000 to invest, I'm going to be your friend because I do not have $12,000 to invest. So, anyway, which investment yields the greater return over 3 years? 7% compounded monthly or 6.85% compounded continuously. So I have two scenarios of where I can put my money. And this is a real life thing. Wouldn't you want to make the most money if you had money to invest? Wouldn't you want to know where your money is going to grow the most? So if that's true, we want to run the numbers, right? We want to run the numbers if we use that 7% account or if we use that 6.85% account. And you may be tempted to say, well, the greater interest rate is going to give us the most money. And that may be true, but depending on how often we get paid, it may not be true. It really has a lot to do with both of those factors. So let's think about that first account. Let's run the numbers for that 7% account. So in this case, we're going to need to use that first we're going to have to use that first formula because that formula is the formula for calculating interest. It's compounded a specific number of times per year. And so since it's compounded monthly, our N will be 12. And so let's sub in the appropriate things in the appropriate places. We're solving for the amount of money that's in that account after a specific amount of time. So we're going to leave this alone. We know that our initial amount of money we're investing is $12,000. We know that our rate, our interest rate is 7% or 7 per 100, which would be 0.07. We know that our N, how many times per year we get paid if we get paid monthly, which is going to be 12. And then that occurs here as well. The last variable we need to tackle will be our T value, which is time. And that's going to be 3 years. So we're going to put a 3 in here. So once you have this all in place, you're just going to use your technology to find the appropriate answer. So try crunching this in your specific technology. Your calculator, a scientific calculator works fine here, or if you want a graphing calculator, that works fine too. The thing that is the most important aspect probably, or where many students make errors, is this all needs to be part of the exponent, okay? So crunch those numbers and you should get an output of your accumulated value is $14,795.11. All right, so let's run the numbers for that second account. That second account is paying 6.85% compounded continuously, which means we're going to use the other formula. Okay, so if we are compounding continuously, we just need to put the right things in the right places here. P is still 12,000. Our interest rate here is different because it's a different bank account, right? It's 0.0685 because we've taken 6.85 per 100, 0.0685. And then we have kept that in the bank for 3 years. So we're going to go ahead and crunch this number here, and we should end up at this value. Your accumulated value is $14,737.67. So these accounts, we start with 12,000. We grew these accounts by almost $3,000 in the course of 3 years. But this account over here is a little bit greater, and so that's really where we would want to put our money. The account that pays 7% compounded monthly will yield a greater return. And you would want to make a statement like that. After you've crunched the numbers and shown your calculations, you would want to then interpret your answer. All right, that does it for this video. In the next video, we're going to talk about how do we solve exponential equations when we can express both sides as an exponent with the same base. We'll see you then.